Well, change of plans. I figure the only way I'm going to see whether or not, like, the pistons in there are just completely horribly scored and the cylinder condition is to pull the head. Now, somebody tried taking this head off and they snapped 2 bolts, and my theory is they snapped these 2 bolt heads off and gave up because the other ones don't look like they've been, well, it looks like maybe this one, and this one, you know, because of the paint missing. Maybe they had those out and put them back in after they couldn't get, oh, I don't know, maybe when these 2 snapped they just stopped. I don't think this head's been off recently. These are really tight. They're small diameter cap screws. I can see why they snapped easily. So the key here, I think, is going to be to apply heat and maybe a little bit of mechanical jarring and just try and go easy on these. If I can get all of these out and get this head to slide up off of these 2 that broke off, there might be enough stud left sticking up to get some vice grips on it, and with some heat and maybe some penetrating lubricant, maybe we can actually get lucky and get those 2 out without having to resort to some other mechanical means that I'm not looking forward to, like the dreaded screw extractor. It's moving a very little bit, but I can't tell if that's a twist of the screw, if the screw is twisting, or is it actually moving the threads. Wow, that wasn't working at all. I mean, I can't put too much heat into this thing. It's just cast aluminum by the looks of it. All right, got this one out. I'm sure it's still plenty hot. So, the way I did that one is I heated the head of the screw, concentrated the heat on the head of the screw, and then I gave it several taps directly straight down with the hammer, and then I broke it free. So I'm going to try that on all of these and see how lucky I get. My theory now is, if that works, what I should have done here is, instead of heating the casting, should have heated the screw. I think the reason why that might be working is because the screws are stainless steel, the head's aluminum, so we got 2 very different expansion coefficients of the metals. So when I heat that screw up, I'm actually making that screw expand in its bore, and then as it cools down, it contracts, and with the mechanical jarring, breaks free. That's my theory. Let's see if that means anything. So the sound I'm hoping for is a creaking sound, because the creak would indicate that it's breaking free. Just turning a little bit without making that sound makes me think I'm just twisting. Let's see. Oh, that one might be coming. Yep, that's way too much of a rotation. It would have sheared by now if it was a twist. Well, it's amazing to me how far those things can rotate, how far those heads could rotate before they actually snap. That's how much twist they're capable of before snapping. So the grand total here was 3 successful bolt removals. Look at the oxide. Look at the aluminum corrosion on these threads. So I noticed these bolts are really short, and I was like, what the heck? And now I realize that this cover, these bolts only hold on this cover, and there must be a space underneath there because the temperature sensor was right here. So there must be a water jacket up on the top here. So the actual, because these things seem way too puny to be cylinder head bolts, which makes sense now. So the actual cylinder head bolts must be hidden underneath this cover. And this is the, so this must be the head. This is like a cover, the head, then the cylinders, and then of course the block. So now I'm wondering, yeah, it's looking like that one's gonna have to come out. That one might not have to. It looks like I missed one, maybe two. Oh, dirty pool. I thought I got that one because of the noise it was making. That one snapped off below the uh-oh. That one might be a difficult one to get out. I wonder if I have to take that one out or not. I could see these ends separating, but in the middle here doesn't seem like it wanted to move, so instead of forcing it, I figured I just better make the assumption I should have made right along, which was that this screw right here also holds the cover on. It doesn't just hold this access on. I mean, I think this is a little access port right here. What if this thing has a thermostat in it? No, not only, well, it's longer because it has to go through this cover and the top cover. Okay, so there we go. Now, maybe that middle section will start to lift. Oh, don't use that. Yeah, you don't even have to take the spark plugs off. So, I mean, if this was running salt water a lot and they didn't run fresh water through it when they got home, I think this would look a lot worse than this. I mean, I'm not an expert, but, and if you're wondering what I'm talking about, if you run your outboard or your jet ski or whatever, if you run it on salt water, what you should do when you get back, you know, if you're trailering it, what you should do when you get back is you should hook on your hose so you can run it out of the water safely and flush the system of any salt water. You don't want salt water sitting in here. Of course, if you just keep it on the ocean all the time, that's a whole nother kettle of fish. Alright, so now we have Bonafide cylinder head bolts to deal with. Well, let's see if we're any luckier on those. Tell you what, the guys who built this thing, the engineers, these are some special kind of guys. Why? Well, because there's 13mm bolts, which on a lot of Asian stuff, if memory serves me, I like rarely run into that. Matter of fact, I even theorized that 13 was an unlucky number for them or something. And the 10 was like the most common size you find on just about any Honda you work on or Suzuki or whatever. But nope, not these guys. These guys, cylinder head bolts, 11mm. Unless I misfiled this. No, 11mm. Go figure. I even had a 10 ready to go. Well, when it can spin the whole motor instead of something happening, that's not a good sign. Let's see. Let me try over here. I can get some more leverage on it. Well, that's not bad. That's a good sound. Oh, I like it. Oh, now that's a head bolt. No head bolts were harmed in the filming of this episode. Alright, let's see how bad this is stuck on. Oh, that was almost too easy. Well, there's something I didn't expect. Both pistons are at the exact same height. Oh, but they're going in different directions when I turn the crank. Okay. Well, I'll tell you what. This does not look bad at all. There was more scoring in the Friday night game between the Boston Bruins and the Washington Capitals. Well, there's some discoloration on some areas of the cylinders, and there's what I thought was scoring lines. Actually, is not that at all because it wipes off with my finger. There's one spot right here where there's a scoring line that I can just feel with my fingernail, but that might even be able to hone that out. So I'm thinking I could just put new rings in it, hone the cylinders. I mean, that wouldn't be too major of an operation. Looks like all I got to do is 4 bolts and these cylinder assemblies come off. So I just don't know what the heck was making all that crunchiness. It actually doesn't sound too bad now. It may have even been something inside the magneto housing in the front. Found a couple different people selling, a few different people selling used rotary valve assemblies with the oil pumps on them, or just the oil pumps. $50 or less. So I'm not too concerned about that oil pump. So I think the smart thing to do now, well, you guys are probably thinking the smart thing to do now is to run away from this. Run away from this screaming. I think what I want to do now is I want to see whether or not I have, between what's on this motor, which is just the magneto, and what's left in the for electrical in the other jet ski, if I have enough to put together a complete electrical system. Ignition, at least. I was talking to a neighbor of mine who's worked on jet skis before, and he said one of the things that they found the most frustrating, him and his neighbor, the two of them, between the two of them, they've messed around with several different jet skis, and they found the most frustrating aspect to be the electrical. I actually think that's one of the things that I might be okay with, just because I've got an electronics background. Not to say that that's going to necessarily help me, but I mean, it might. So what I think I want to do is I want to see whether or not I can actually put together an electrical system that will make the ignition on this work. Because if I'm missing like the CDI unit, which apparently they're the CDI and the controller, as they call it, is all like integral in one box. Might even all be in one module, I don't know. But if that's missing, that's a major piece of the puzzle that might be pretty expensive to get. So, yeah, I don't know. So I figure what I'm going to do now is I'm going to see if I can get this cover off of this magneto. I want to see if all that's in here are, what I think is in here is going to be a magneto for generating the power to charge the battery and run the electrical system. And then I also think there's going to be another winding in here, or a pickup that's going to be used as a trigger to trigger the CDI system. So somebody very unceremoniously just chopped this cable off right here. So I'm going to have to, if I am going to be able to use this, I'm going to have to rewire this. And what I'm hoping is that this is just a strain relief, that maybe everything inside here can be spliced and a new cable can be run out instead of splicing it out here. For one thing, this is out really short, and also, well, I guess I could get waterproof splices, but ideally I'd like to get a whole new cable. Oh, this is a multi-conductor. What do we got here? Two? I might have something that actually I could use in the place of that. So I guess first thing is, let's see whether or not there's any chance of me getting these out without snapping them. Well, they're a little better than the top cover there. I got 5 out without breaking them. This one here holds this bracket up here like this. These two both snap that hold this. This is a place to store the spark plug boots. I guess during testing or something, I don't know. Some of them actually started to come out and then stopped and snapped, which was disheartening. Worried about having to drill out or retap those holes if necessary down the road. I'm not going to get upset about it just yet. Tell by the change in sound that it's moving. There we go. It's these top ones here that are still seized onto the what's left of the bolts. Definitely up here. Alright, so not a lot to see in here. Looks like we got a flywheel. And this is where the starter engages. So I'm not going to be able to see the coils and pickup or any of that stuff without taking this flywheel off, which I'm not going to do. What I can see, which is what I was really hoping to see, is that this cable, where it comes through right here, all it does when it comes in is, there's a piece of foam here. And all it does is it makes a turn. Look at this. How about them apples? Can't go much nicer than that. It makes a turn and it goes right into some connectors. So, this cable being sheared off by somebody is not anywhere near as horrible as I initially thought. This wire had come in here and like went uninterrupted all the way down to the coils, then I would have had to have cut into those wires and spliced in with connectors like these that are already in here. Or if the wires were really short before they went into the magneto, for instance, that would be bad. But in this case here, it seems like there's going to be plenty of wire. Right now I'm going to undo this nut, this plastic nut right here. I'm hoping this acts as a strain relief. There we go. So that's like a rubber bushing strain relief. The way this works, this is a tapered rubber plug. That's a tapered hole. So as this nut is tightened down and pushes this down into the taper, it squeezes around the outside jacket of this cable. So it does two jobs. It actually acts as a strain relief, but it also makes a watertight fitting around this jacket. So I'm just going to put this on here so I don't lose it. Well, that's really got a lot of crud in it. All right. So now, with that out, I can do this. I can pull. That's interesting. There's wires here that are cut off, or a wire that's cut off. That's probably factory. What they're probably doing here is they're probably using a 5-conductor wire. Is that a 6th? No, that's just a nylon cord. They're using a 5-conductor cable in this application, and they only need 4 of the conductors, so they're just cutting this off and leaving it. But this is good. This is good news. Now I can consult the service manual and do some resistance checks. Well, so much for measuring the resistance of these things and to determine whether or not they're good, because it turns out in the service manual, Seadoo basically wants you to use their Seadoo part number blah blah blah, which is a little test box. And that test box isn't just measuring resistance, because they tell you to hook it up and crank the engine. So they've actually got some little idiot box with lights on it that are going to light up and tell you if when you're cranking the engine, if you're getting any voltage coming out of the magneto, for instance. So it's interesting. I think they're calling this the magneto, which must be for charging the battery and developing the power. And then I think they're calling this the generator. But I'm pretty sure this is going to be the coil that's going to give the impulse to actually give a kick to the ignition coil. It turns out this particular model, it's got an electronic box in it, but I think they're calling it an electronic control, and that is not a CDI. I'm basing that on the fact that when I look at the wiring diagram, they're sending one of these wires directly over to the ignition coil. So I'm going to skip ahead to plan B, which is plan B is to get the electrical box out of the other donor jet ski, and hopefully that has everything in it that I need, and hopefully everything's fairly intact. And what I want to do is see whether or not I can wire this up temporarily on the bench and just crank this over with like my impact driver or something, and see whether or not I can actually get spark.